I'm a researcher out at the FRF. I work very closely with Brian here on this project, SandSnap, and the rest of my projects are AIS and like nav portal related for navigation under Ned and Brandon and Marin Kress. So those are kind of my two bailiwicks. Uh, like Tanya said, I want to keep this light and polite. We've only got about 30 minutes worth of stuff to talk about. So if you have a question, please pipe up or put it in the chat. Our team here for this project, we've got Brian McFall, we've got myself, also Brooke Walker and Shannon Stever are the rest of our round out the ERDIC team. But SandSnap is a big collaborative effort. We've got a team member from academia. Shelley Whitmire is our citizen science expert. We've also got Dan Buscombe of Marta Science. That's a small business. And he is our machine learning experts. We've got two different machine learning models under the hood of SandSnap, and he is the architect of both of those. We also collaborate very closely with Mobile District's spatial data branch, geospatial data branch. They are the guardians of our actual web application in our Azure instance. So I know Brian and I have probably both talked about the actual, what SandSnap actually is, but today we're talking about version 2.0. So the changes that made it bigger and better, and how we made those changes and how much better it's gotten. And that's what we'll spend most of our time talking about. So is this changing for you guys? Whoops. Okay, did it just change, Brian? Am I changed?
Yep, you changed it.
Awesome. Okay, so I don't know who's on this room. I just want to very quickly talk about what SandSnap is in case you're like, I have no idea what's going on, David. So what do you mean by SandSnap? SandSnap is an interactive web application. You can get to it from this link right here or the QR code here in the upper right-hand corner of this slide. What it is it allows citizen scientists to go out to the beach and actually collect grain size distribution measurements using the app. And the way it works is you, any prospective citizen scientist who wants, can go out to the beach. You take your cell phone and a US coin, go out to the beach, put the coin down on the sand, and snap a picture of the sand with the coin in the image like we've got here. Go to this app and you upload it. It'll ask you a couple of questions. It'll pull your location and the timestamp from your image. It'll process that and it will return to a user dashboard the grain size distribution of that particular sand with a little fun fact and the original image and that cool stuff. The stuff that goes on under the hood of SandSnap. So once you upload that image, it goes to the app, uploads it to the government cloud. We use Microsoft Azure. And once it gets to the government cloud, it's processed with two different AI ML algorithms. The first one is a coin detection model. So it detects this coin and figures out how big it is. And we use that to convert our pixel space grain size results into physical space. And the second app is the one that actually, the second machine learning model is the one that actually calculates the grain size distribution here, calculates it in pixel space, and then we convert it. And that's how we get to our grain size distribution. The reason why SandSnap exists is we are trying to build this nationwide beach grain size database. Brian and I have talked about this already plenty of times, so I don't want to belabor the point, but it doesn't currently exist beyond SandSnap. Grain size is one of the largest sources of uncertainty in morphology models. It limits opportunities for coastal resilience, and particularly with the emphasis on beneficial reuse by the Chiefs memo, it also limits opportunities for beneficial reuse of dredged sand. It also helps us to save money. So a big emphasis of this is trying to help the Corps save money because it's expensive. It's hard to go out there and bag up some sand and then ship it back and sieve it. And here, all you have to have is your phone. You can take a lot more grain size estimates. You can also take a lot more spatially, so you can have higher spatial and temporal resolution. Transitions are going really slow here. Okay, all right, there we go. Okay, so with that like basic setup out of the way, we're going to talk mostly today about SandSnap version 2. So the changes that have been made in version 2 that make it better than version 1. Brian's going to come on here in just a second and talk about some quality of life upgrades to the main SandSnap site, so the one that all of the users see. Also to our admin console, we've made some changes to basically our Brian and our special console that we can see to have more control over the site. He's also going to talk a little bit about some changes to the instructions and the submission forms that have been made, I think through a demo that he's got planned. Then I'm going to come back after that. I'm going to talk about the upgrades that have been made under the hood. So these are things that a user is not going to see, but changes that have been made to the coin detection model to make it more robust, changes that have been made to the actual grain size model to make it better, updated image processing routines. The combination of those three things makes SandSnap both faster and improves our accuracy by quite a bit. We'll also talk about some improved error handling. And by this, I don't mean like the accuracy of the results. I mean like what causes images to fail. How can we coach users to submit better images based on the returns that they get when images do happen to fail? Then lastly, I'm going to wrap up with some updated filters and features that didn't quite make it to version 2, but they're going to be coming in version 2.1. These aren't things as significant as wholesale changes to the grain size model or coin detection model. These are just additional filters and features that we had planned on adding that make this a little bit more user-friendly and help us to filter out some of those images before they make it to the actual, like the poor images before they make it to the actual grain size model itself. So with that, Brian, if I can let you go right here. Do you want to share your screen?
Yeah, I'm pulling up my screen right now. All right, so you should be seeing my screen right now. Right now, if you Google the word SandSnap, the first thing that should pop up is our ArcGIS website, which is the SandSnap web application. We made some updates and things, nothing like extreme to where you might look at it and get confused or baffled, but there were a lot of things that we wanted to streamline, make a little clearer. So the interesting thing about SandSnap is because it's a web application that we want people to use on their phone to actually upload images, we have to make the website view correctly both in a web or on a desktop and on a cell phone. And actually, Rose also has it set up to where it has a certain format if you have a tablet too. So every page that you see actually has 3 different versions of it, but they all have the exact same information on it. So what you're looking at here, this is the desktop version of it. Previously, we just had where people could take a SandSnap now if you already have like images to upload, learn more, look at the database, or get some of the most recent data. Some of the biggest changes we made this year have actually been to the learn more. So right now, we've always had kind of a description about here's what SandSnap is, and here's all the things the goals and why it's important. We also have a link that talks about, this is our database, and it shows a lot of the images from the recent submissions. Gives you a total SandSnap count so people understand, just how many we have. We have instructions on how to collect a SandSnap, and these didn't actually match exactly what we had for the SandSnap Now instructions. But one of the biggest changes that we've added, just cosmetically, to the tool itself is we wanted to not only make SandSnap a useful tool for researchers and things like that, but to actually get people engaged. We wanted to come up with some clever ways to get people to actually think about, why does the sand look different? Why is it larger here? Why does this look like it has shell, and why does this look like it has quartz? So we actually created this little Learn About Sand tab, and we kind of created this little quiz, and it kind of gives you a little introduction about here's some basic information about sand, and it talks about, as you walk through this, there's a little bit of information, and then there's a question like compare these 2 images. What is similar and what's different about these? And you can click show the answer, and it pops up an answer, and it gives you like a little background information about, notice how this one has dark sand, and look how this one's finer. And it goes into different things like that. You can also goes into geography, look at how the different colors, goes into mineralogy, and each one of these things gives you an opportunity to kind of learn just a little bit more about sand and why it's valuable or why it's interesting. A lot of this would be things that a geologist would just kind of take for granted. But, anybody looking on the beach, we try to make some interesting kind of fun facts and things like that. So people go, oh yeah, you know what? This actually does have more shell, or this is actually a different color. So, and we give some basic instructions to understand why some of these would be different. So that way, folks get a little education while they're also collecting samples for us. Those are the big change. That was a major change. It took us a while to actually collect all those images, because those images are actually SandSnaps that people have submitted that we've turned around and then pulled them together to make some interesting statements from them. This is the data viewer. It's very similar to what it was before. If anyone opens up and clicks on the data viewer tab, you can actually open and close the sidebar. But this will show you all the most recent submissions. For those that haven't used this data viewer before, I'll just go ahead and give you a quick example you can zoom in to particular sites and click on a point. Oop, sorry. Click on a particular point. It'll actually tell you, it'll show you the image, give you the grain size, give you a little fun fact about similar size, a beach with a similar size. Excuse me. But if you zoom out, all this information, all these SandSnap points, these are SandSnaps that people have submitted. We have a lot here in the United States. There are also some over in Europe and a lot in Australia. All these SandSnap points logos, if you click on them, you can download the image. You can also get all of the gradation information that we process from the image itself. So if you look here on this bottom bar, this actually shows this is an object ID. This is when it was created, location. It also gives you the cross shore position, whether you're in the swash, on the berm, or in the dune, the coin that was used, and then it gives you the gradation information, everything ranging from D10 to D90. So that would be the percentiles. In addition to that, it also tells you this is a SandSnap version that it was used to process. So in case you come and you download a lot of data and you might go back and try and re-download those same points later, if you get different results, odds are our SandSnap version is updated. So as we make improvements to the to our processing, we turn around and we back process all the historical submitted images. So that's a good thing to note, that be sure to check if your values end up being different. With that, there's also, I'll just point out one more fun fact. We have a leaderboard here. This has all of the states that have the highest number of SandSnap submissions. So if you see your state on here and it's not number one, I encourage you to go out to your beach and actually take some more SandSnaps. Go ahead, David. Did you want to chime in?
No, Tanya put a question in the chat. She said,
Oh,
are all of those Atlantic and Pacific Islands real coordinates?
let's see. I think so. Yeah, because oh, thank you for actually pointing that out. So everywhere we have a SandSnap logo, that's where we actually have SandSnaps. So this is Hawaii here, and we do have quite a few SandSnaps from that area. All these little blue dots, these are actually Rob Holman imagery. So Rob Holman is a professor, or a retired professor from Oregon State University, and he collected a pretty massive data set of samples. And it wasn't just him who collected them, but since he already had this massive data set where people mailed him sand from all over the world, he photographed them with a microscope, and rather than just leaving that this amazing data set to never be found again, we went ahead and put it on SandSnap so you can actually see those. You can also get more information about these if you click on the tab here that says additional images. These additional images, these are all Rob Holman submissions, and it tells you who the person was that actually donated the sand to Rob, when it was taken, the photographer, some basic information, lat long, and things of that nature. Now these we don't actually give gradation. We allow the people or anybody who wants to actually pull gradation from them, because they have all sorts of different types of sediment and things like that. And we didn't want to train our model against microscope images. We wanted to actually use cell phone imagery. So that way, whenever somebody goes out to the beach and collects a SandSnap, we want to make sure that those actually work. So all these dots that are out here in the middle of the ocean, those are true, but they're not actually SandSnaps. Everything that has the SandSnap logo, these are true SandSnaps that were collected for our program. Yeah, great question. Thank you. Final thing I just want to wrap up with is the the leaderboard. It's a great opportunity for you to represent your home state, let people know where you're from and that your beaches are important. And the more SandSnaps you get, the higher obviously you move on the leaderboard, but also the more data you create for coastal managers and folks to make more educated decisions. Finally, there's a recent submissions tab. This the look of it's changed slightly, but it's basically, this gives you an opportunity to see all the most recent submissions. So if you click and submit a SandSnap and you want to see what your results look like, so after that 2-minute processing time, then you can click on this and it would actually show you your results and give you some information. And with that, I'll go ahead and pass it back to David. Okay, Liz, are there plans for the Holman collection to be analyzed? It'd be interesting to compare the error from phone images versus microscope. Yeah, that could be very interesting. The only catch is Rob Holman's data has been collected over decades. So a lot of times the beaches that they're collecting from have are they kind of just look different. So especially if there's been recent nourishments and things like that for the areas where we're getting a lot of these submissions for SandSnap itself, but we put them in there just to for completeness. At this point, we don't have plans to analyze them, but just to make them available, and we're kind of kicking around that idea in the long run. Oh, okay, Gabriel, great question. Is there a way to compare samples from different beaches within the tool? Um, so there is, if you just zoom in on your different beaches, you can export the data and then it exports it as a CSV. So you can quickly Excel and compare how they look for the different locations, and you can quickly locate where they are on the map itself. So it's not within the tool, but you can quickly export it and make that analysis if you're looking at different areas of your beaches, or different beaches, excuse me. All right, back to you, David.
Thanks, Brian. Are there any areas that are most in need of SandSnap images? Go back to the data viewer to see. Yes,
Yeah.
there's many areas.
Yeah, there's lots of areas. I would say any beach that you're interested in or that you visit regularly, if you care about it, you should take some sand snaps there. So if you the there's no such thing as too many sand snaps because it's just a matter of processing the data and storing it. So it's very it doesn't take anything on our end or very little on our end to collect thousands of these. But the data that you collect, obviously you can increase it temporally, so you can get both the winter and summertime gradation changes and start to capture some of that, and you could also capture some of these spatial variations. So I know David and I, we've talked about before where you may go on the beach and you're walking along and you see one kind of beach sand gradation, and you see areas, pockets where there may be different kinds. So that it's kind of interesting. It'll give you the opportunity to take as many as you want. And it only takes, less than a minute to squat down, snap a picture, and upload it. So we don't have a specific area. All beaches, all sand beaches are what we're targeting right now.
There's a lot of questions that just got flashed in the chat.
Yeah. So Tanya asks, how are we handling the temporal component of viewing and downloading the data? So if you zoom in on sort it in Excel based off the temporal component. I think we're going to talk about it a little bit later, but we are coordinating with the California Shore and Beach Preservation Association. They wanted to have a biannual Snap the Sand event where ambassadors, yep, it's kind of corny, but ambassadors were going out to all the beaches and snapping pictures. And they wanted to do it in the fall and then in the spring to capture both the summer and the winter gradation. So there are people that are specifically looking at temporal gradation. I've also been working recently with a colleague from Coastal Frontiers who's looking at a long stretch of coastline in Florida or California as well, and he's going out there twice a year as well. So he's going to be trying to capture some of this temporal variation as well. Okay. David, if you're okay, I'm just going to start running through these questions. That way we address them, and then chime in if you have anything to add or to improve.
Okay. Are you gonna type answers while I talk? Is that what you're gonna do?
Well, no, I'm just going to go ahead and verbally knock them out. That way.
Yeah.
Okay, so Charlene asked, are there any thoughts on normalizing the leaderboard data by population or shoreline or something? We're not considering that right now. We figured right now the idea is just to get as many as possible. And, obviously California has a huge shoreline, but so does Florida. But California has, 2 to 3 times as many samples. So right now we're not necessarily looking at normalizing it, but it would be interesting to consider that in the future once we really start getting a lot more. Liz asked, the new features on the web page look awesome. It'd be cool to select snaps to add under data checkout that makes a single CSV for easy comparison. Yeah, that's a good idea. No additional feedback there, but we'll definitely take that into consideration. And Tanya mentioned she likes the idea of having maybe 3 leaderboards, one on count, quality check, etc. So yeah, that could actually be pretty interesting. We could also have a criteria about how many are actually being uploaded and how many are actually processed. So these are pretty fantastic ideas. And Kelly Legault mentioned that she loves the idea. She already texted it to her neighbor, and we'll be out to Volano and San Augustine Beach to get some snaps there. Perfect. Now, since Kelly's already mentioning going out to the beach, if anyone is interested, we also have water bottle stickers, which are kind of cool. They're bumper sticker quality, so you can stick them on your water bottle in case you forget the word SandSnap, or if you're old and you're like, what's the name of that thing called? Snapchat. It's not Snapchat, it's SandSnap. We get that all the time. And it's not CoSnap either, it's SandSnap. But this is a quick little QR code. You scan your phone to it, reminds you what the name of the tool is. We also have these little business cards that actually have instructions on how to take a SandSnap. Brooke Walker helped us create these, and she actually glued a little coin there. So one of the big problems we often hear is that people forget to bring a coin to the beach. But we also have the QR code on that too. So if anyone's interested in getting some of these, or if they plan to do, I don't know. I know there are a lot of parents out there. If you're going to talk to your kids' school and you want to talk to them about SandSnap and include that and give little handouts, just email me. I'm more than happy to mail you some of these business cards and water bottle stickers. So Brennan Banks asked, what are some next steps for getting SandSnap data implemented into projects at districts? So that's a great question, and we're kind of stepping into that. I started off, SandSnap was an abstract idea. Can we get this to actually work? And now that we're starting to get to it and we're actually getting a lot of feedback and stuff like that, I think it's actually going to be really useful, particularly for monitoring after beach nourishment projects. So we want to start working with some district colleagues to actually try and get that implemented and see how this could be worked into their workflow itself. We currently don't have that yet, but that is kind of our next steps, is to pick up a district or two that's actually interested in using this tool and actually coordinating with them to actually monitor some nearshore berms not nearshore berms, some beach nourishments afterwards. Liz said, maybe you said this, but how do you spatially separate and aggregate nearby snaps into a single point? Tell you what, I am going to, so how do you aggregate them? So you don't. It'll give you all the grain size information for all the points that are in your viewing area. So as you zoom in on the data viewer, it immediately starts to downsample and filter the plots at the bottom. And then from there, you export the CSV, and you can either downsample or aggregate them yourself manually afterwards. The goal is to make sure all the data is freely available so that anyone could process it in whatever different way that they may want to. The other thing to keep in mind when you're exporting this data and looking at it, the results are only as good as the image. So some results are probably going to be more accurate than others. But if people take several images and one of them looks like it's a wild outlier, you should quickly go back and look at the images themselves to make sure that there's not a reason for it. Oh, sorry, Liz. So to clarify, how do you know if 2 snaps are in the same beach point? Do they have distance thresholds? No, there's no distance thresholds, but what we do is whenever you upload the thing, it finds your position via cell phone towers, and it will point it to a spot. So I haven't seen any where it's the exact same point. There's some where it's pretty close, but as you zoom in, there's always been a difference there. So I know personally when I go to the beach, I like to take a snap at like the beach dune on the berm and closer to the swash zone. And by doing that, I've never had an issue where they appeared at the exact same point, even when it was a very narrow beach. So it almost always has a gap there. If you do see any spots where it's like the exact same point or two measurements at the exact same point, let me know, because that's probably an error on our web app. But otherwise, it should be a slight gap in them. Hope that addresses that.
If you wanted to take sand snaps at the exact same point, Liz, there's room for notes in the SandSnap submission form. So like you yourself could type in, I don't know, survey point one or whatever, and you'd have like multiple, you'd have the same note, and you could search for that on your when you're looking through that CSV file. It's just it's very unlikely, as Brian said, that the actual GPS would pick up the exact same point, if that makes sense. Are we good?
Think so, David. Tell us what's under the hood. Tell them how it works.
Yeah. All right. I was getting all these questions. I'm really excited about that. Okay, so Brian just went through like the SandSnap front end and what users see in the user experience. And I'm going to spend most of the rest of the time talking about what's under the hood and what's different about what we've got here in version 2. So some of these slides you've probably already seen basically a version of these slides before. So my layout for talking about what's different is I've got what we have that's the same as version 1 and 1.1 here in black. And then the stuff that was in version 1 that is no longer there is X'd out. And then what is added here in version 2 is shown in blue. So that's like the structure of this. So there's 2 different machine learning models under the hood of SandSnap. Fully convolutional neural network, just like the first version. The first big difference with the coin detection model is that with the first version of SandSnap, individual machine learning models were not as good. So we had 5 different machine learning models that to do the coin detection, and we aggregated those results that were presented and passed forward. Now we've got one coin detection model to rule them all. It's just one model. It's been trained with a lot more data. And in that bigger data set, we have a lot more nickels and pennies and dimes. So most of our submissions are quarters. But as a result, our coin model is better with nickels and pennies and dimes. This also gives us a slight speed increase because we're not having to run 5 different coin detection models on the same image to aggregate those results. Once we have our coin pixels detected, we run a random sample consensus model on the coin pixels to estimate the diameter of the centroid. That has not changed. The purpose of this model has also not changed. So we're trying to figure out where the coin actually is so we can crop it out, and then how large is it in pixels, and that's how we convert from physical space to pixel space. Here is where we get our second big change for the coin detection model. So the SettingNet model, which is our next model that estimates the actual grain size, runs on the square 1024 pixel sub images. So what we did in the first version, you have your image that you submit, we crop out the coin from that, and then we would take the rest of that image and we would divide it up into these sub windows. These would have some overlap to them. But because they're 1024 by 1024 pixel sub images, we would often have a lot of sub images when we were just doing our sub windowing all across the image. We could have up to 20, depending upon the resolution of your phone camera. And we would then run the grain size model on all of those sub images and aggregate those results as well and pass them forward. Now we are searching for just the best of those sub images. So we have some code that goes in there and looks for the most in focus square sub image, and it passes that forward to the actual grain size calculation model. And this is where we get our big speed increase here. We're only doing one sub image for each parent image. So a parent image is the one that the user actually submitted. And we just do one sub image from that parent image instead of like 20. And that gives us a very big speed increase. So SandSnap is a lot quicker now than it used to be. Next up is our actual grain size model. Just as an aside, here in the upper left-hand corner, this is what I mean by a sub image. So this right here is a square part of an original image. You can imagine this was a larger image from someone's cell phone that had a coin in there. The coin's cropped out, and now we've got just this nice square image that goes to SettingNet. So the name of the model that we use for grain size is SettingNet. It's the same as it was for the type of model is the same as it was for version 1.1. It's still a deep learning model. It still estimates grain size information. You can download your own. You can clone his repository and create your own SettingNet model anytime you want. That's the link. Still estimates 9 numeric grain size metrics, and it still uses your GPU for computations. Our big change with this version of the SettingNet model, our grain size model, is it's been trained with a lot more data. So we're up to 266 sets of sand samples and then paired images that we use to train the model. And the accuracy overall has improved of SandSnap as a result of these changes. How many sets of samples do we have with the first one, Brian? Was it like 90 or 65? I can't remember with version 1.1.
Yeah, I think it was around 86.
Yeah, yeah. Anyway, so this part that's X'd out here, less than 12% D50 error from the in-situ test images. This right here was the error of just the SetiNet piece of SandSnap. So if you perfectly knew how to convert pixel space to physical space, this would be your error in the actual SandSnap results that you got, because there would be no effects of the error in the coin detection model on these results. We had suspicions in version 1 that the errors were not as good as that overall. So I'm talking about the overall SandSnap errors were not quite as good as that. So we're being more precise about this for SandSnap version 2. So this right here is the total error, the total accuracy for SandSnap version 2. And what I mean by that is, what does SandSnap tell you the gradation results are? What does the sieve tell you the gradation results are? How do those compare? For all the images that we actually have physical samples for, I'm showing 3 of our grain size metrics on the screen. We've got 9. I'm just, to make it brief. So we got D25, D50, and then D84. On the y-axis of each of these plots is the SandSnap prediction. On the x-axis, we have the sieve results for the same metric. We've got our 1-to-1 line, and then we have some error statistics shown here in the upper left-hand corner. We got bias, we have the mean percent error, and then we have the median absolute percent error is this APE right here. We had suspicions that version 1 was biased fairly high. The bias on SandSnap version 2 is much lower. It's close to 0 for all of them. It's biased high for these 3 that I've shown here. The mean percent error is down below 15% for most of our grain size metrics, and the median absolute percent error hovers around 25%. It gets a little bit higher for D84. One thing to note is that as you get further away from D50, so you get to the tails of the distributions, the results tend to get slightly worse, and that's just, the tail of the distributions are just harder to measure. So we feel a lot more confident with our SandSnap version 2 results, and we're moving forward with our journal paper, which I'll talk about on the next slide, because we're feeling a lot better about these results. Some improved error handling we've got here, and here by error I don't mean like the accuracy of SandSnap. I mean this image failed for some reason. Version 1 was not handling the errors, even the errors that we knew about, correctly. It was also not handling the subdivision of images like we thought it was. And the reason for that is we were not as smart as we got later with version 2 about how we interface with the developers at Mobile Spatial Data Branch. So if you have plans on putting your tool in Nav Portal, or you plan on building some type of web tool with the Geospatial Data Branch, this is of script where it had diverged a lot from what I had on my machine. And we got much better about this with version 1.1 and now with version 2 that's carried forward. We have very clear divisions of responsibilities. So OPJ is responsible for the front end Esri tool. They upload the images, they handle all of that. And then what gets passed to the code that I am responsible for now is a folder with the images to process and a file that tells me what is the coin and what is the image name. So to basically correlate what type of coin that is with the image name. I am responsible for everything that happens after that until we get to the actual answers that I want to be sent to either the admin console or the user. But that I mean like the errors I want to send, the answers I want to send, everything in between is all on me. And that's like more stressful for me, but also makes it a lot easier to troubleshoot problems, because there's no mystery about what's on my machine and what I'm seeing and what we're seeing up in the cloud when we run this. And it also makes it much easier to make changes now that we've got these clear delineation, because all I have to do is say, here's a new Jupyter notebook that goes here in this section of the code. because we've gotten a lot more images since we did version 1, we've also seen more possible combinations of errors that we have now accounted for. One of them that it doesn't pop up too often, which is why we hadn't really thought about it, is if your original parent image is too small. So like I'm not able to crop out a 1024 by 1024 pixel square sub image just because the resolution of your image you submitted is too low. That's not very common because most cell phones have higher resolution cameras than that. The one that is more common that we didn't have accounted for before and we do now is if your coin is too large and too close to the center of the image, I might not be able to find a square section of that image to use for SandSnap just because the coin is basically blocking. There'll be a piece of the coin in any part of the image, if that makes sense. We're also passing through a lot more information to the admin console, which is for Brian and I to troubleshoot what's going on with SandSnap. We're passing through how many coin pixels did we actually find, and then what are the actual millimeter per pixel values, which is going to let us decouple the error of the coin detection from the error associated with the grain size estimates. One thing to note is that this is still ongoing, and it will probably be ongoing for the life of SandSnap. So here to the right-hand side, we have an example of one of these errors that we still don't quite, not able to handle just yet. This is an image that was submitted to version 2. We've got what SandSnap thinks the coin pixels are is shown in red. So SandSnap's just killing it at finding this coin right here at the bottom. Super sure that's a coin. This would give you a beautiful result for that ransack model. However, it's also equally sure that this rock right here happens to also be a coin. So it's throwing off our diameters for this particular image, and that's why this particular image failed. So this is just, we're just working through it. New stuff for version 2.1. So these are some things that not something so sufficient to rise to the level of like a whole new version of SandSnap, but some filters that we need to work on and some new filters that we need to add. So Brian and I, how am I doing on time? Yeah, I got plenty of time. Brian and I hired an ORISE student from UNC Wilmington. He started back in July. His name is Jacob. He's doing really, really well for us. And his job, while we have him under contract, is basically to do two things. One is to pick better filter thresholds for the filters that we already have in place, but we just have them super lax. And what I mean by that is when we first released SandSnap, we weren't wanting to kick back every single image unless it's absolutely perfect because we don't want to make some deliberately bad images and to tune our filters so that we know, look, if it's this bad, it's definitely going to give us a bad result. We need to kick it versus ones that we can go ahead and let pass. He's also going to try to speed up some of those filters that are just they're a little bit slow because we're trying to have there not be such a huge lag between when you submit a SandSnap and when you actually can see the results. Some of the other filters that we don't have yet that we want to add are filtering and or correcting for shadows or foreign objects in the image. Another thing that Jacob has already made some progress on is the ability to de-blur images using this open source de-blurring code called NAFNet. I'm going to show that here in a couple of slides. And then he's also going to look into adding non-US coins. This could be either really easy or really hard, depending upon how well the coin model is at least able to detect the pixels from non-US coins. So if it's easily able to detect the pixels, it's as simple as just adding the millimeter size of that coin to SandSnap so we can do the conversion. If the coin detection model starts to freak out, then we'll have to go back to the drawing board and train a new model to include those coins. This is an example of a SandSnap 2.0 that also failed. This was claimed to be a US coin. You can see very clearly this is a Canadian order right here. It says Canada right there on the top. So what do I mean by good versus bad SandSnap? So what are the filters that Jacob is trying to implement for us? On the right-hand side, this is what a good SandSnap looks like. We've got our coin. It's in the bottom right-hand corner. It's mostly sand in the image. The image is in focus. To the left-hand side, all of these are less than optimal SandSnap images for various reasons. So this first one here in the left-hand corner, this is obviously not a SandSnap. We've got our coin, and we don't have any sand, so we want to boot that one out. Here in the bottom left-hand corner, this one is too blurry, and B, we can't see the entire coin. So those are the two reasons why this one might want to be kicked out. The blurriness is something that we're hoping to be able to improve with the NAFnet. Here in the upper middle section, you can see that this coin is actually the phone was at an oblique angle to the bed slope when this image was taken. So we're assuming that our millimeter per pixel values are consistent in the X and Y coordinate direction. So we need to have the images taken with your phone as parallel to the bed as we can possibly get. Here further down, this one, we're too zoomed out and the coin is pretty close to the center of the image. In the upper right-hand corner, the biggest problem with this is that this is a Texas state quarter, and we can't have that with SandSnap. Yeah, no, I'm just giving Brian a hard time. We're too zoomed in on this quarter, and the quarter is too close to the center of the image. And we've also got shadows here in the image, and we're trying to be able to correct for this the shadow right here. Lastly, you can tell we obviously got a foreign object here in this particular image. So really quickly before I wrap up, Jacob has already done some work on using NAFnet to deblur. So if you go, you can Google NAFnet and you can clone their repository, and with that repository comes some images you can download to test out how their code works. And it turns out it works awesome. Works super well. This is one of the demo images here to the left. You can see how blurry it is. Once you've run it through NAFnet, which is a machine learning model to deblur, you get this image here on the right. So that's all great. What they don't tell you is that these demo images are 48 kilobytes. This is a 48 kilobyte image. So the average SandSnap image, you can imagine your cell phone camera is over 4 megabytes. Some of them are over 10 if you have like a really beefy cell phone camera. And using one SandSnap that was 4.2 megabytes crashed my GPU immediately. Like it immediately crashed it. And it was like, nope, definitely can't do this. So until this gets to be not such a memory hog, we're kind of in a holding pattern. One possibility is that we could break the image up into pieces and try to deblur individual pieces and then stitch the image back together. But Jacob is trying to make some progress on some of the other filters before we circle back to that potential workaround. Brian talked about this, so I'm just going to skip it. I'm going to skip this one too. I do just want to mention that, and I'm sure Brian would echo the same thing. Like we would not be here if it weren't for the hard work of Dan, the hard work of OPJ, the hard work of Shelly, the hard work of the ERDIC team, and all of these universities and collaborators that sent us sand samples to sieve and images to process to go train our model. So we owe a lot to their efforts, and it's been truly. So to wrap up, SandSnap version 2.0 is online. If you saw that database from Brian, the model that has been used to process all of those images is version 2.0. So the back processing is all complete, and if you just submit a new SandSnap, it will be processed using version 2.0. We're feeling really good about the error results, and that's super important because our journal paper, we still don't have a single journal paper on SandSnap, and it's time to finally push that thing out the door. We're going to write one. We currently have an outline in draft that is in collaboration with Nick Cohn and the Aeolus team. So Nick already has a built-in use case for using SandSnap to answer some windblown sediment transport questions about how using the full grain size distribution can improve your estimates of windblown sediment transport. And then finally, we've got this improved filtering that I talked about that's coming in FY24 with version 2.1. And that's all I've got. I'm happy to take more questions. Brian got so many more questions than me on his component, so I'm feeling a little put out.
Yeah, you got too deep into the neural networks, man.
I did. I know. Yeah.
We're about to. No, it's going to blow up in a second. Just give it a second. I want to ask real quickly on this JP that you guys are working on with Nick's team. Is this more for the Dune response tool, which is the kind of the faster one-line tool that is looking at sediment transport at different spot locations up and down the coast? Or is it Aeolus?
It's Aeolus. It's Aeolus, right, Brian? I mean,
yeah, it's Aeolus, and Janelle Skaden gave a talk, a technical discussion about it at some point. It was a portion of it where They wanted to emphasize the importance of Aeolus and aeolian transport, how important it is to actually have the full gradation, not just implement just a simple D50. And they're using SandSnap because we produce from D10 all the way to D90. They're showing how if you use the full gradation versus just a single D50, you can get a very different outcome for your aeolian transport. And then also for areas where you have lots of samples, you can actually import all these into Aeolus and use the full gradation and show how that influences the aeolian transport as well. So there's two different parts, but both of them are going to be specifically using Aeolus.
All right, fantastic. Yeah, because I remember talking about that specifically with the Dune response tool, but I know that Janelle is doing that work. If anybody's interested, that was back in June, and I think that's up on the website too. So, some of Janelle's work. Okay, let's open it up for questions. Feel free to unmute.